All right, open up your book to section 10-2. We're on page 496 in your book. The title of this section is Cartesian Equations for Conic Sections. The objective here is given a Cartesian equation for a conic section, transform it to other equivalent forms, and sketch or plot the graph. And then secondly, given the graph of a Cartesian section, write a Cartesian equation. That's the part we're going to tackle here in this discussion here is, given a graph, be able to write the Cartesian equation. All right, so let's start with an example. Example 4 on page 502. It says, find the particular equation in the center radius form for the hyperbola in the figure there. All right, so they gave us a sketch of this. And I guess it should be obvious from what they already told us in the description of this problem. But let's write down what we're working with here, what kind of conic it is. Again, hopefully we can definitely tell that from the sketch this is a hyperbola, but they did tell us that in the problem. The other thing we should write down, or note at least, is what direction this opens up in. This is opening up to the left and the right when we look at our hyperbola there. So this opens in the x direction. And the reason why we want to note those two things is because if we go back to the center radius forms for a hyperbola, there were two of them. I needed to know whether it was opening in the x direction or the y direction to help me know which one of those it is. And clearly now we've noted that it's opening in the x direction. So that tells us the equation that we're dealing with. Since it opens in the x direction, that means that it's the x term that's the positive term. The y term is going to be negative. So let's write down that equation then. It was x minus h divided by your d sub x squared. And then it's minus, again, because of the fact that it's opening in the x direction is how I know where that negative sign shows up. Y minus k over d sub y squared is equal to 1. All right, I like writing that equation down because that gives me kind of a game plan here of what I need to do to answer the question. I need four things. I need an h, a k, a dx, and a dy. Once I find those four things, we are all set to write our equation. So let's go for the hk. The hk, remember, is the location of the center of this thing. They've got that marked for us, actually. It's where your asymptotes intersect there. And so where does that fall there? That looks like that's at -4. And that looks like that's up at 2, it looks like. So -4, 2 is the center of this. So our center is at -4, 2. That's our hk. So actually that's half the work there, or half the values that we needed to find at least. So now let's find our dilation factors, our d sub x and our d sub y, our x dilation and our y dilation. Because this opens up in the x direction, that tells me, again, because it opens up in the x direction, that tells me that I can use dx to help me figure out, or I can use the graph there to help me figure out what dx equals. Because that dilation factor tells me how far it is from the center to the vertex. So if I measure this distance right here, that distance right there, from the center to the vertex, that is what dx represents. Again, that's because it opens in the x direction. If it was opening in the y direction, I'd measure that distance, it'd be vertical, and it would tell me my d sub y. So count that out. What is that? 1, 2, 3, 4, 5. Looks like that's 5 units. So my d sub x, I'm going to go ahead and just write it that way. D sub x is equal to 5. If you want to write out x dilation equals 5, that's fine to do. Now, to find out your y dilation, that's not too difficult here. And that's because of what we know about the slope of these asymptotes. Remember that the slope of the asymptote is the change in your y's over the change in x's. That's what slope is. And we measure that, in this case here, by taking your your y dilation and dividing it by your x dilation. It's the ratio of those two. So if I think of this as being the run, this dx that I've marked here, and this as being the rise of a run, that right there represents the slope of my asymptote. So this must be what dy equals. If I measure this, I've got 1, 2, 3 units there. It looks like this is 3. So it must be that dy is equal to 3. d sub y is equal to 3. Again, Because this opens up in the x direction, I can measure the distance from the center to the vertex. That tells me my dx. And then from the vertex to my asymptote, that distance will tell you what dy equals. All right, we're ready to write an equation then. Let's do that. Put it right here underneath the graph here. So I'm just going to take that equation I wrote over there and fill in the values we came up with. So I've got x minus h we said was a negative 4. I'm going to go ahead and write it that way, x minus a negative 4. If you want to write that as x plus 4, fine. But I'll just do it this way so you can see that we're actually using the negative 4 there. And then it's divided by your x dilation, which is 5. We square that, and then I subtract y minus k we found was 2. Divided by our y dilation we said was 3. We square that, and that's equal to 1. Right there is our equation for that hyperbola. All right, let's try that again. Slightly different conic, though. This time, take a look at example 5 there. This time they give us this parabola here. It says find the particular equation in vertex form this time for the parabola. Now, again, they did obviously tell us what conic we're dealing with, but I'm going to go ahead and note that. Okay, that it's a parabola. With a parabola, I need to also know what direction it opens up in to know the equation. Again, if you go to your vertex form there for a parabola, there's 2 of them. And the difference between the 2 is which direction it opens up in. So this clearly opens in the x direction. If you also want to indicate that it opens up to the right, that's fine, but that won't really affect our general equation that we're going to write down here, our vertex form that we're going to write down. So with that, I have enough information to write my equation now. I know my equation for a parabola that opens in the x direction is x is equal to, and it's h plus a times y minus k squared. X is equal to h plus a times y minus k squared. So I've got 3 things defined here. I need an h and a k and an a. All right, so let's start out with I think the easiest one, which is the vertex. The hk is why we called this the vertex form, is because that's what hk represents. So we've got a vertex, and it's at the point, what is that, negative 10, and then that's up at 3, it looks like here, right? So negative 10, 3. All right. And now we have to find out what a is equal to. To find out what a is equal to, we're going to have to do a little bit of work here, actually. They gave you a point on your parabola, and including the vertex, but they gave you another point that this goes through. They've marked that as an x-intercept. That's at what? It looks like it's at 8, 0, right? Is that x-intercept? So I know an x and a y value that my parabola goes through. So I can take the equation here. I can plug in the h value and the k value that we know. I can plug in the x and the y value that I know from the x-intercept. So I'll know h and I'll know k. I'll know the x and the y. The only thing left that I'll have there is what is the value of a. I can solve to find out what a is equal to, in other words. So let's do that. So let's plug in those values there. So we've got x is the 8 minus, oops, not minus, but it's equal to. The h value is what we came up with as our vertex. That's the negative 10. Plus a is the number we're looking for. Y is the location of the x-intercept. That's at y equals 0. Minus k we said was 3, and that's squared. So again, using that x-intercept, that 1 point they gave us, I can come up with what a is now. So solve this. Add the 10, so we get 18 is equal to negative 3 squared sounds like 9, so it'll be 9a. So divide by 2, so it looks like a is equal to 2, right? So there we go. We've got everything we need to write our equation. Let's write our equation here. Put that over here on the left again underneath the graph. So just write the equation and plug in the values of h and k and a, and we've got ourselves the equation of this parabola. X is equal to, it's going to be a negative 10 plus the value of a we said was 2 times y minus k, which is 3, squared. There is our equation of that parabola with a vertex at negative 10, 3, opening up to the right. And I didn't mention that when we found this value of a, but remember that since we got a positive value there for a, that should indicate that this opens up in a positive direction. On your x-axis, positive directions are off to the right there. So that makes sense to us that we should end up with a positive value there. If it was opening up in the other direction, I'd end up with a negative value there for A. All right. Let's take a look at one more example here. Look at example 6 there on 503. This time it says to transform the equation in example 1 into the form of ax squared plus, this is the polynomial form, bxy cy squared dx plus ey plus f equals 0. So we're trying to go from one form to another here, it sounds like. Let's go back to example 1 and refresh our memory here. Example 1, I think, was that ellipse. Yeah, example 1 is the ellipse that they gave us. Let's write down that equation. It was x minus 2 divided by 5 squared, and then y minus 4 divided by 3 squared, and that's equal to 1. All right, so they want us to transform this from this center radius form to the polynomial form is really what they're asking us to do. I would suggest the first thing to do is try to get rid of the fractions in here. That'll probably make the problem a little bit easier. So let's do that first. Let's actually split up these fractions that we're squaring and write it as the numerator squared, x minus 2 squared, and then actually square the denominator. 5 squared is 25. Do the same thing over here, so it's y minus 4 squared, and that's over 9 when I square that 3. And that's equal to 1. All right, so now let's get rid of the fractions. We can get rid of the fractions just by multiplying by the product of these two denominators here. So if I multiply this whole thing by, what's 25 times 9 is 180 and 45. It's 225. If we multiply by 225, that should get rid of our fractions here. So let's go through and do that. So when I multiply this first fraction by the 225, of course, I've got 225 over there divided by 25, which gives me 9. I'll have 9 times x minus 2 squared. That's where that 9 is coming from. It's because of the fact that 225 divided by 25 is leaving with a 9. Do the same thing here. When I multiply 225 times this fraction, I've got 225 divided by 9. That's going to give me 25 times y minus 4 squared. And of course, 1 times 225, that one's pretty easy. That's just 225. All right. Now we actually do need to square out these numerators, but I've waited till this point here when I get rid of the fractions to do that. So let's leave the 9 out front and square these binomials. Remember, when you square a binomial, you get 3 terms, a trinomial. There's a middle term that's got to show up here. So make sure you end up with a trinomial when you get done. X squared minus 4x plus 4 is what we should have when we square that. Leave the 25 out front here for this other binomial. Square him out, and you end up with y squared minus 8y plus 16 is 225. All right, that looks pretty good. Let's multiply the 9 through and the 25 through the parentheses there. So we get 9x squared minus 36x plus 36. Multiply the 25 through, 25y squared. 25 times 8 is 200, so negative 200y. And then 25 times 16, well, that's double the 200 that is found, right? So that's 400. And that's equal to 225. So actually, we have it written in that form. Well, I shouldn't say we have it written in the form yet, but we have all the terms written out. Now we just got to get it in the right order here for the form that we're looking for. So let's do that. The first thing that we write down is the x squared term, which is actually the first one we have here. So that's the 9x squared. And then it's the xy term, which there's no xy term. I'm going to go ahead and write it in here. I would say in general you don't need to write the 0xy, but I'm going to go ahead and mark it so that we know we considered it was there potentially. And then the 25y squared goes next. That's our quadratic terms. Now for the linear terms, so the x goes first, minus 36x, and then minus 200y. And then finally, the last part is the constant. Now with the constant, you've actually got 3 terms here, so you got to do a little bit of combining here. You got 36 and 400 over here on the left side, and then you got to combine it with the 225 that's over on the right side. So I got to subtract that one. because this needs to be set equal to 0. So 436 on the left, subtract 225 sounds like 221, or 211, sorry. So plus 211 is equal to 0. 436 minus 225 is 211, yes. All right, there we go. We've got ourselves the polynomial form. That one right there isn't too bad to go through. I mean, it does take a little bit of algebra, and we got to remember to square those binomials correctly. But we end up with the polynomial form. The next question that we're going to tackle in the next part of this is, what if I start out with this polynomial form and I want to get back to the center radius form? How do you go about that? Definitely is going to require a little bit more work to go through that. But we can. All right, that right there is the end of this section, or the second part of this section, section 10-2.